quantifiers as well. And a window popped open there. So the notation for existential quantifiers is basically the same thing. You're going to have x, you're going to have t, you're going to have some range predicate, and you're going to have another predicate p, and then instead of the for all symbol, you're going to have the exist symbol. So you're going to have something like that. So let's do another example. So in the last example we had, if I flip back to that page, we wanted to state that all elements in L are even. Now let's say we want to state that at least one element of L is even. So what would that look like? Any ideas? So basically, let me write it out actually. We want to state that at least one element of L is even. So in the previous question, we wanted to state that every element of L is even. Now suppose you want to state at least one. Yeah, so it's basically the same thing. You just do exists. There exists some x, and again, it's of type integer, and basically x is a member of L, and the predicate is that mod 2 of x equals 0. Okay, so that should be clear. Let's see, what else do we have? We can also have nested quantifiers. So nested quantifiers. So you can have a quantifier within a quantifier, and you can do that for both existential and universal quantifiers. So now let's say we have, let's do a slightly different example. Basically, let's say we have a list of lists. So suppose you have a list of lists of type int. So let me draw an example in a second. So that would look something like this. So you have a list, and within that list you have another list, and that's going to have type int, and then you'll have another nested list, and so on. So assume you have something like that. Let's say that equals L, and then you want to state that every element in this nested list is even. So state every element in L is even. So any ideas on that? So now we have a slightly different list. We have a list of lists. So what would that look like if you wanted to state every element was even? So I'll give you guys a few minutes to think about that. Again, assume you have the mod2 function. So we're going to need that again. So feel free to drop your answers. By the way, I think the way you specify the type, like if you have a list of a particular type, the way you state is like the type of list, it looks something like this. So if you had a list of integers, for example, you would do something like sequence of z. At least that's what I remember from when I took the course, unless Dr. Mackey showed you guys something slightly different. For all L list, I in L. Yeah, so what you put there looks right. So basically we're going to have for all, let's say, so we're going to have, you can think of it as a nested for loop. So we're going to have sort of an outer loop, and then we're going to have an inner loop. So let's say we have a variable s, and we'll say it has type. So I'm actually going to define this type here. Let's call it, let me erase, or yeah, let me erase this. So let's call list. So this is going to be sequence of Z for integer. So I believe that's the right way of specifying the type. You can do it sort of directly, so you could say sequence of Z here directly, or you could just define it in another sort of variable like that, and then just use that variable. So you could say S of type L, and the predicate is that S is a member of L. So again, L is this bigger list, or this outer list, and then S is each sublist. And then basically we're going to have a nested quantifier, and then basically we can say that for all, let's say X, that are of type int, we're going to have X, the predicate is that X is a member of S, and the property that's going to hold is that mod 2 of X equals 0. And then we're going to have two brackets. So is everybody clear on that? Any questions? So that's what that looks like. So again, you can think of it as a nested for loop. So you can think of the first part of the quantifier, this part, as your outer loop, and then you have an inner loop that does that checks through all the sublists. Any questions? Second question. So let's continue. So we can also have tuples. So tuples are nice. Basically, the way you define a tuple is you just do something like if you wanted a point object, for example, that has a x and y property, you would basically state it like this. So point equals tuple of, and then for some reason, when I was looking at the sort of the guidelines for the MIS, when you specify a tuple, you don't do something like this. So you don't do x is of type integer, like you won't use a math notation. You do instead, you actually write out int. Not sure why it's like that, but that's just how it is. So x, y, they're integers. And then basically, if you had p, suppose you have p of type point. So if you had p of type point, that means you can do p dot x and p dot y, and that would give you the corresponding value for x and y. So very similar to how you would do it on actual code. So again, let's do a simple example. Let's say you want to write, so suppose you have, a list P of points, meaning it's a sequence of points. So if it looks something like this, basically, you have x1, y1, then you have x2, y2, and so on. So you have a sequence of points, and then you want to write a method that's going to check if all points are on the grid. So suppose you have a n by m grid. So you have an n by m grid. Check if all points are within the grid. And again, this is a list of points, so you have to be a little careful. So I'll give you guys a few minutes to think about that, and then feel free to drop your answers. And this is check. So that wasn't readable. So you want to check if all points within this list of points is within the grid. So any ideas on that? So any ideas? It's kind of quiet. I'll give you guys maybe a few more minutes to think about it. So again, you have this list of points, and then you have an n by m grid. So that's like n rows, m columns, and you want to check if all points are within the grid. So anybody? Yeah, that looks right to me. So as someone mentioned, this is going to look something like this. So for all, we're going to do, yeah, that looks right as well. Yeah, there's a number of ways that you can write it. So basically, it's going to look like this. So for all P, and P is going to have type point, such that P is a member of capital P. So again, capital P is this list of points. And then you can think of it again as iterating through the list. So you're going to look at this point, then you're going to look at this point all the way till the end of the list. So you're going to have, each element is going to have type point, and then the predicate is that P is a member of capital P. And then basically the property that's going to be true is that P dot X is less than N, because the sort of the X coordinate has to be less than the number of rows, and P dot Y has to be less than M. So because that's the number of rows, so that would be less than M, because M is the number, Y is the number of columns, Y is the column coordinate, and then M is the number of columns, so that has to be less than M. So any questions? So they're relatively straightforward examples. It's just, when you first do this stuff, it takes a while to get all the syntax and everything right. So you can write it out like this. And then you could do something slightly neat. So what you could do is, let's say, you could do in bounds. You could define another function in bounds that takes a single point P. And that basically does what this sort of predicate is stating. It basically does P dot X is less than N and P dot Y is less than M. And then what you can do is you can take the predicate or the quantifier we had earlier, and you can rewrite it using the method we just defined. So instead of stating this whole part, which can be lengthy, you can just use sort of like a helper method in your MIS. So this is another thing that you can sort of do on assignments and exams. So you can do something like that. So this is slightly more readable because it doesn't have this long predicate nested inside. So we can use like this separate helper method. So any questions? Will be given in a questionnaire. Yeah, so just assume it means n rows in a matrix and m columns of a matrix. Okay. Yeah, like a matrix. Yeah, if you were given this question on like a test, it would definitely be more clear. So, what's wrong about it? No, n is the number of rows and m is the number of columns. Not the other way around. Okay. So there's one more example that I had. Basically, let's say you want to state that, or let's say you have a list S, or set S, I guess. Suppose you have, or actually, I think the right term is sequence, not set. Yeah, so we haven't talked about sequences. It's very similar to sets. So we'll see this in a second. So a sequence basically maps to an array when you actually code it. So suppose you have a sequence S, and you want to state that state all elements. State all elements in S are distinct. Or in other words, there's no duplicates in this array. So how can you state that using everything we've seen so far? And this is our last example. After this, we'll write these up in LaTeX. So any ideas on this? You want to state that every element in a list is distinct. So if you have something like this, for example, that's distinct. But if you were to have, let's say, like 1, 2, 1, 3, 4, that wouldn't be distinct. So you don't want any duplicates. So any ideas? So element 1 type, element 1s. Yeah, that looks about right. Yeah, so you're on the right track. The only thing is we're not dealing with sets here. So we basically, yeah, that's a good point then actually. I can briefly talk about that. If you have a sequence, basically the notation is very similar to actual programming. So if you wanted, let's say the length, that's just S, like vertical bar, S vertical bar. If you wanted, let's say an index, you would just do SI. So that's basically the ith element. If you had a 2D array, you can do Sij, just like you would in programming. You can also do like sublists, so you can do like 0 to, let's say, like, that would be like from 0 to the length of S minus 1. So, and then you use sort of the two dots as to specify like a range, basically. So this means 0 to length of S minus 1. Okay. So maybe if you guys want to think about the question again, now that you've seen this syntax for sequences, to see if that slightly changes your answer. But what you mentioned, Ahmed, is it's on the right lines, but maybe you can rephrase it in the sequence or the language of using a sequence. Yeah, good. Yeah, so that's what it would look like. Basically, you would have something like this. So for all, you can do I is of type integer, because you can think of this like an index in a for loop, so it's going to be an integer. And basically, I is going to range from, basically, I is going to go from, let's say, 0 up to the length of S minus 1. So this basically means, this is specifying like a range for I. And then you can say, you can do like a nested for loop. You can say you have another J, which is also of type Z, or integer. And then basically, J has the same range. J goes from 0 to S minus 1. But you can do this slightly more, I guess, efficiently. You can say J goes from I plus 1 to S minus 1. But if you put 0, that doesn't mean it's wrong. And then you go from, yeah, and then our predicate is, and let me make this a bit smaller, just so we can fit everything. So our predicate is that, oops, let me switch back to my pencil, that Si does not equal Sj. So any questions about that? That was kind of a loaded example. No, so I wouldn't think about the implementation or efficiency or anything like that, because again, this is a specification, right? It states what, so you shouldn't be thinking about that. So it doesn't matter if I do I plus 1 or 0. It's just that, those are both equivalent. But again, you don't want to really think about performance in this case. So I'll actually just state 0, just so to make that more clear. Okay, any questions? And just to note, this tutorial will be slightly longer. Like usually we do in like a 50-minute lesson. This lesson will probably be just about an hour, maybe slightly over. And then again, the second half will have just like an office hour for questions. So any questions about this? You can put I and J in one for all though. I don't think you can. So you need sort of a nested approach in this case. Any other questions? Okay, is there a problem with this? I don't think anything's wrong. All right, so this would actually be I plus 1, just so they're never equal. So yeah, that was actually the reason. it should be I plus 1. So they're never equal in that case. Yeah, thanks for pointing that out. Okay, no other questions.